Hi, my name's Fran Lasowski, and I'm doing my PhD in chemical engineering with Dr. Heather Sheardown, looking at ocular drug delivery for use with children. The diseases we're looking to treat require a drug to be delivered to the back of the eye. This is traditionally done using injections. Needles in the eye are scary for anybody. It's particularly daunting with children. We wanted to come up with a better approach. And the way we want to do this is to use the sclera, the white part of your eye, to have a device sit on that and the drug diffuse to the posterior chamber. We've come up with two materials to do this. The first is a polymer-based system that looks a lot like a contact lens. And in fact, we started with contact lens materials, incorporated our drug, and looked at the release from these materials. When we do drug release, we're looking to be in what we call a therapeutic window, and that's shown by the green lines. If you're above this window, you're associating it with overdosing, and that has a lot of side effects. When you're under the window, you're not actually delivering enough drug to treat the disease. If you look at the red profile, that's something that happens with treatment options like eye drops, where you end up increasing the concentration rapidly and then it decreases, and you actually spend very little time in that therapeutic window. Instead, we want a profile that looks more like the blue line, where we get into the window and we stay there. With these polymer materials, we've been able to show therapeutic window values for about 7 days. So that's been really good news for us. We then looked at a second device, which is made out of lipids. And the lipids are shown in the upper corner. They form what's called a bicontinuous phase. And what's really important about these are those red tubes. Those represent water channels. And why these are unique is we want the drug to be in the bulk material, the white portion, and it's slowly to diffuse into the red tubes and then into the eye. We've been able to create these materials so they have the properties that we need for use in the eye, namely that they're sensitive at the right temperature. And we're now conducting tests to see if they can give us that same sustained drug delivery in that therapeutic window for a long enough duration to be appropriate. So what we've been able to do so far is show two promising options for drug delivery with children to the eye that doesn't involve needles. Thank you.